Now, the second thing that we need to have is actually earthing and bonding. So this is important. So suitable earthing is required, and to complete to make the earthing system complete, because we need to have earthing as well as bonding to make a complete earthing system. So as we have described before, for lightning protection system, we can have type A or type B earth termination system, the one that we put in the soil. And we describe about parallelizing the down conductors and so on, to reduce the potential difference by making the current flowing to many ways. So to reduce the potential between two internal systems, the following methods may be applied: by bonding, as well as shielded cables and shield cross sections, as you can see here. So this is the earthing termination, type B, because it's a loop there and it's buried, and the down conductors are shown there. The bonding network is actually a low impedance bonding network is needed to avoid dangerous potential difference between all equipment inside the inner LPZ, and this can be realized by meshed bonding network as shown here. So as you can see, the earth termination is under the soil, but for each layer of the building, you can see many metal works, and these need to be bonded together, as well as the incoming lines need to be bonded to the earth termination system. So the whole thing become earthing system. So the earth termination system plus the bonding with all the connected wires, as well as for each level we have metal works, we call this as earthing system. So these are methods of bonding. Here many layers need to be bonded together. Another method of bonding here, we call it basic configuration, mesh or star configuration. Integration into bonding network shown here. And the main physical things there is actually called bonding bars. The bonding bars is actually where all conductive services, gas, pipe, and so on, power lines, is connected to, including SPDs. The protective earth also connected to here. Metal components of the internal system, cabinets, enclosures, racks also connected to this bonding bar, as well as magnetic shielding of the LPZ also connected to this bar. So the bonding bar, for efficient operation of it, the following rules are important. So it has to be of low impedance, should be connected to the earthing system by the shortest possible route rather than a longer one. Material and dimension of the bonding conductor shall comply with standard. There is certain dimension that you need to comply, and SPD should be installed so that there is a shortest possible connection to the bonding bar. For example, your red face need to go to bonding bar, so the SPD should be straight to the bonding bar as short as possible. Or yellow face, blue face, neutral, through SPD. But the ground wire from the power line goes straight to the bonding bar. Okay. So again, this is explain the bonding at the boundary and so on. And I think there is an example somewhere, including the wiring. Okay, we're going to look later on. And meaning to say, it's not good for us to have SPM if we don't do the bonding properly. So the criteria, the summary is, we need bonding bars if you have multi-story building, each level we have bonding bars that we connect all the service lines as well as our electrical lines and signal lines to the bar to make sure the equipmentization is achieved when there is, for example, a lightning strike of where the earth potential goes up and all the bonding bars will go up as well, and all the system will go up as well in terms of voltage. So we need to bond them properly. Now, we have SPD, some is bonded directly to the bar, some through SPD. Okay, now magnetic shielding and line routing. If we have shielding, we need to construct the shielded properly, or we can also do what we call line routing technique. Okay, line routing is actually to minimize the loop electromagnetic interaction. So either we use special shielding by special walls or grid-like structures, or we can use shielding of our lines by line routing or by shielded lines or conduits to make sure there is no coupling for the lines inside the structures. For shielding, special shielding, we can use metal braid, we can use metal tower, we can use cabinet, it's like continuous shield. We can use metal control cabinets. But for the line routing, we can use line current, shielding of line. We can use lightning current carrying shielded conductors, or we can use cable shielding. So shielding here can be the special shielding for the wall as well as line shielding. Also, we can use line routing for the internal line to reduce the magnetic interaction with our loops by minimizing the loop area. So we route the wires so that the root is minimizing the area for the coupling. So we can use twisted pair, for example, or we can make sure that the line produce minimized loop area. Okay, line shielding already mentioned just now. For the general case, we should always apply line routing, meaning minimize the loop, because even though we said maybe radiation is minimized, but we don't want any effect of radiation into our system. Now, we have already described the coordinated SPD system. This is actually zoning or minimizing the surges using SPDs. So just repeat again, number 5 is SPD. So it can be for the power line as well as for signal line. So based on either it's for power or for signal, which is a lower voltage, we have different standards. So the standard are mentioned here. So these are for the power lines. We should use these SPDs, these standards to test and to, for power system, this one. For signal system is the second one, number 21. This is for a test requirement. For selection of the proper device, we use these standards. Okay, mentioned there. Okay, this is an example of IT equipment protection where we cascade the surges using SPDs. This is an example of SPD itself, whereby we have a device here. It's actually used to minimize the surges and so on. Okay. Again here, these are for the first stage, which is LPZ1. We're using for power line SPDs, and for stage 2, we use another type of SPD, and stage 3, another type of SPD. Okay. So this is application in the structure we put at the boards or main board or switch board as shown there inside the house. Another technique, last one, is actually we call it isolating interfaces. If we want to use this, this is also okay. To isolate between incoming line or incoming system to the next system or the next zone. For example, using isolating transformers or opto isolators. So we need to have someone professional to do this, to design as well as to maintain the system. You see, the SPD also need maintenance, so you need to manage them well. So these are the steps how to design. As you can see there, earthing system need to be available and so on. Okay, you can read on. And these are the detailed steps, as you can see there. This is from the appendix. Okay, I think we're going to finish here. We're going to stop here. Any question?
No.
No question.
No, bro.
Okay, so I think we're going to stop, and I will see you again next time.